Hello, this is John Sprovieri, Chief Editor of Assembly, and welcome to our latest webinar, Modernizing Automotive Assembly, Why Upgrading Legacy MES is a Business Imperative. This event is sponsored by Velotic. Wherever and however you are watching, thank you for making us a part of your day. Our presenters today are Richard Porter, Discrete Industry Lead for EMEA at Velotic, and Vikram Mankar, Principal Product Manager for MES at Velotic. Now, before we get started, please take a moment to scroll down and explore the webinar console. You can download handouts, you can click on the speaker images to learn more about our presenters, and most importantly, you can submit questions or comments anytime using the Q&A box. We will address as many questions as possible at the end of the presentation. Today's webinar is being recorded and will be archived on our website, assemblymag.com. And now, without further ado, I will turn it over to today's first presenter, Richard Porter.
Thanks very much, John. Hello, everybody. Thank you for joining us today. As just introduced, I am Richard Porter. I'm Discrete Industry Principal, which means I'm responsible for our product sets and how we go to market with regards to discrete market, everything from aerospace through to white goods, but focus for today is around automotive. Vikram, do you want to just say hello?
Yep. Hi, hello everyone. My name is Vikram Mankar. I'm the Principal Product Manager for our Velotic Proficy MES suite. And good morning.
Okay, so we have an agenda. The agenda, for many of you, you won't know the name Velotic because it is a brand new brand. So I'll do just a couple of slides to explain who we are. And then we'll talk about modern automotive manufacturing challenges and the reason why the historic systems that we have been involved with need to change. Vikram will then take over and he will explain how we are creating the next generation solutions and how that will address those challenges, and we'll have a few takeaways at the end and a survey. So to introduce Velotic, we have existed since March, basically. We are the together, the integrated suite, or integrated portfolio of three product sets, ThingWorx, Proficy, and Kepware. These are tools that came from GE Vernova, which was the Proficy product set, and ThingWorx and Kepware came from PTC. Those products actually historically worked together anyway. The Kepware product was white labeled by us. ThingWorx was a client that has been regularly used with Proficy. So although these product sets are from different vendors, they do work together. They are an integrated portfolio. We're a pure play software company. We don't sell any hardware. We are independent of whatever systems you have on your shop floor, whatever systems you have in your business system, whether you're an SAP or a BON or whomever, that's what we do. To give you an idea of our scale, we're about 1,200 people. We're very much a global company. Our revenue is around 350 million turnover a year. We have over towards the right 8,000 active customers, of which we then break them down into discrete, hybrid, and process. Discrete is the focus for today and the focus for Vikram and myself. So to explain those three layers again, we've got Proficy in the middle, the bright orange section in the middle. Those are our operational systems. They are everything from manufacturing execution and taking orders, issuing those orders and the plans to the shop floor, driving that through the manufacturing process, collecting the data, putting it into the right format, such that it can be analyzed or used for regulatory purposes or whatever you want to do with it. The Kepware level below provides data integration and aggregation. We have many hundreds of different interfaces, so pretty much whatever you see on the shop floor we can talk to. And at the top level we have ThingWorx, which provides the dashboarding and the analytics, and that's a connected worker interface to the users, be that an operator or be that management or be that maintenance or whomever. And we operate with many well-known blue chip type customers, names that you will recognize. Today's focus is across that top row, and in particular the automotive section in the middle. And then just to say, hey, we're not a new player here. We've existed for over 30 years. The Proficy product set, which is today's focus, that has been implemented for over 30 years. You can see some of the logos where we are extensively used. The point of this picture is to say that we worked everywhere, whether it's a press shop, a body shop, vehicle assembly, powertrain. We've operated everywhere. Whether you're looking at SCADA or genealogy, we've had that experience. We've got a huge track record. The blobs on here, if you look at a purple will be one company. So I don't know which company's which, but you could imagine that purple might be Nissan. And so you can see Nissan where we've operated. So for each of these customers, we have covered the whole gambit of automotive MES manufacturing. When we look at the challenges for automotive manufacturing, we see a change in the marketplace. Obviously, there's a lot of change with regards to EVs and hybrid vehicles, a lot of change in terms of the pace at which new vehicles are being brought out. That's having an impact on manufacturing. And at the same time, there is a lot of change in terms of, we all talk a lot about analytics and artificial intelligence. So we want to run our plants back better, and we want to make better use of the technology that's available. And that is driving a need to change the manufacturing operation management systems. We tend to look at the challenges. The way we try to approach this is look at what the problems we're seeing with our customers. So that could be driven by corporate initiatives. That could be driven by things that are happening in the manufacturing process. We see a lot of market volatility at the moment with onshoring and supply chain. So that has a huge impact in terms of challenges. That demands for us some certain outcomes. It may be functionality. It may be visibility on where materials might be. It demands an outcome that could be looking at process improvement or compliance, which then leads to increasing your revenue by selling more vehicles, reducing costs by taking costs off the manufacturing process, being more efficient, or just the more intangible elements where you're driving up quality, increasing customer satisfaction, which then creates customer loyalty and so forth. The challenges we see. I'm going through this quite quickly at the moment, so the intention is to get to the part around what the actual technical offering is. So we look at things like regulation, IATF regulation, the complexity of supply chain. A vehicle has many thousands of parts, and we have to manage the flow of those materials into the manufacturing process. One that comes up an awful lot now is around talent and labour. We're not seeing, well, we know that we're not seeing new people coming in. We have a lot of intelligence retiring, a lot of knowledge to capture. So how do we deal with that shortage of labour? Material management, making sure materials arrive on time. I mentioned earlier about the speed at which we see new products coming through, the need to efficiently bring a new product into the production lines. Cost and management is obviously one that we always see. The second from bottom is one where there's a lot of focus. We attend a lot of events, and people want to make a lot better use of the data that's available. We're actually overwhelmed now. At one point, 10, 15 years ago, we struggled with data. There wasn't much data. It was hard to get to. Now we're overwhelmed, and how do we see the wood from the trees? How do we actually take knowledge from that? And environmental elements as well. That then results in outcomes you want to see. You want technology that allows you to be compliant. You want technology, for example, the third item, you want a user interface that captures the knowledge of the experienced employee and presents that in the right way at the right moment in time, be that powertrain or assembly or wherever, at the right moment. You need to be able to manage the material. You need Kanban type system, just in time delivery. You need data in a format that allows all these new analytical tools and AI type tools to make use of that data, to get that knowledge, that intelligence, for it to be able to predict where your manufacturing process is and what things you need to do to address those issues or run better. Okay. So the problem we see, and you see the X in the middle, those challenges we've just been talking about, which have now moved over to the right-hand side, they are in some ways incompatible with the traditional type of MES solution that we see in most manufacturing plants. So they're very often based around SCADA and databases with custom tables, which are hard to understand. So you end up with disconnected data silos that we can't interrogate. We end up with a mix of user interfaces that are sometimes as on-prem and local, sometimes a web front end. That makes them very hard to update. They're costly and inflexible. Take typically 1 to 2 years to implement. With the speed we're seeing new products being introduced, that's just not acceptable. We need to be able to do it faster. We use legacy protocols like OPC-DA, but there's a lot more coming through. We have very complex custom interfaces into ERP, and scaling that just involves adding more systems with more complex products. And the final one on there was just difficult to upgrade. Historically, we've typically, as a supplier, waited for a period of shutdown, often in the summer, where we do these. We need these extended periods of shutdown to implement the new system, and that's becoming not acceptable. We need to be able to update things in real time, so in near zero downtime.
What I'd like to talk to you about is going back to the challenges Richard was talking about in your traditional or legacy MES systems in the automotive space. So we talked about SCADA being the primary driver, and it's understandable. If you think about automotive, if you think about the need for integration with your control systems and the need for decision-making from an execution standpoint to be real-time, not near real-time, but real-time. You want those torque tools to get the information in real-time. You want the decision on whether or not that part in station is good or bad real-time. You're not waiting for an execution engine to run logic and come back 3, 4, 5 seconds later. In fact, if you're in automotive, you understand your round-trip response times need to be in milliseconds. And we've seen specs around it has to be less than 100 milliseconds because that's part of your takt time. And you cannot have an IT system occupying the majority of your takt time. So those are key imperatives when you think about, why, in hindsight, why the automotive industry adopted SCADA-based platforms to do this. Having said that, we've created a problem. We've created a problem around cost of ownership. We've created a problem around upgradability. We've created a problem around customization and modernization, which is what we're trying to solve with, at Velotic, what we're calling Proficy for assembly operations. And really, if you think about what we're trying to do here is, if I keep features and function aside, but if you think about the personas here, the key personas here are the manufacturing engineer, the plant engineer, and the operator. There's a lot of focus on the operator. So those are, yes, they are important. They are the ones consuming this information. But in many times, and again, those who are in the automotive industry understand, building a vehicle, building an engine, building a part in 50 seconds, the operator has not a lot of time to look at a screen. And so their focus is doing the job. The screen is there as a information screen. It's just providing basic information screen. But really the operator focus is on assembly, is on making the part, is making sure the machine's running, it's making sure the part is correctly being assembled. So we've been focusing on all three personas, with majority of our focus being the manufacturing engineer and the plant IT or OT engineer. The manufacturing engineer, because they're responsible for a lot of the contextual models that drive execution. And then the plant IT engineer, because they own the systems. They are the ones responsible for making sure that the systems are running 100% of the time. So uptime, making sure that the upgrades and the network availability is there to support the execution part. And so that's sort of the personas we are looking at to solve this primarily. And so what we're solving for is really, we look at IT, OT best practices. So it's not just OT best practices, but also IT best practices. And the IT best practices are all around declaration-based configurations. If you think about traditionally how MES systems and even SCADA platforms are deployed, in the past you would have servers, bare metal servers. Somebody would install CDs, run through the software installation process. The same kind of process for upgrades as well is you go through a highly manual process. Life has changed. I mean, things have changed in the IT world. It's all declaration based. You have recipes. You have, if you're in the cloud world, you have Helm charts. You're not sitting in front of anything. You are at a CLI terminal or UIs that basically drive configuration for you. And that's what we are seeing in the market is the need for that kind of a touchless way of configuring your MES. And not just from an environment perspective, but also your model. So being your contextual models being model driven. So your source could be an ERP, a PLM. It could be a layout of your plan. So the idea is my manufacturing engineer shouldn't have to go sit in an admin tool and create a layout model or an equipment model or material model or any model for that fact. There is always a model somewhere in the plan. It may be in a rough cut diagram. It could be highly sophisticated in a PLM or ERP. And that's where, as a software, we are tapping into is that's your start. And that becomes your way to quickly configure and deploy and bring value to the MES. And then obviously from an IT advantage standpoint, yes, we want to bring in capabilities around hybrid architectures. One of the things we are designing this solution towards is this concept of central configuration and on-edge execution. So the idea being I can have a central configuration from a manufacturing engineering standpoint. And as an operator, I have edge execution happening at either the line level or even station level. And if I do lose connectivity to my central configuration, which may be hosted in the cloud, in a data center, centrally in some form of environment, I should be able to continue executing as an operator. I don't have to have the dependency that environment needs to be available the whole time. So again, thinking through that flexible architecture and obviously low latency protocols around these edge architectures. You don't want a heavy footprint in the plant. And that there are low latency technologies today. You have protocols like MQTT that allow you to have that high-speed exchange of data. And so those are the technologies we are bringing into the product. And we'll get a little bit about those here shortly. But think through as you are looking or going through your own infrastructure, how do these challenges, how do they manifest and what are you doing to solve those? And what we're saying is the way we solve these is what you're seeing on the right-hand side is really looking at it not just from an architecture perspective of servers and VMs, but also in terms of how you are architecting it to help execution and configuration. And then the overall integration with systems like ERP, PLM. And then, not to leave out AI, because I'm sure everyone has AI in their mind. How does AI help? And really the key to our platform that we're developing is AI being sort of the back end driving this, AI also being the front end in terms of interacting with those personas. And so you'll hear here, as we talk more about our Velotic strategy, we'll hear about Velo AI, one of the AI assistants that we're developing that will sit across all our portfolio, including assembly operations. And then we have other AI tailored applications that we are starting to incorporate across the portfolio. Going to move to the next slide here. So quickly cover some key capabilities. And by the way, I just want to bring out one key point here. This is not Velotic building software and assuming, hey, we think we know what we're doing and let's push it out to the industry and see if they'll bite or they'll use. We're actually powering with a global powertrain manufacturer. So this is a co-development effort. So it's industry working with industry for industry. So this is not something we're building in a silo. We are actually proving this capability as we speak and then bringing it to market for the automotive for the automotive community to look at and to really realize the value that this co-development will bring to you. And you'll see typical features around data management, whether it's bill of process, route management, materials. So all of those key capabilities that a traditional automotive manufacturer requires are being developed and incorporated in the solution. So again, this is not a one-off. This is not something that's building in silo. We are actively building with a manufacturer. And the key driver for this is not just from a next-gen MES or a new paradigm in terms of how MESs get developed, but this is also looking at brownfield versus greenfield. So our key driver for this is how do we look at brownfield sites with all of these SCADA systems and all of these custom MESs, and how do we move them over to this new solution? So that is one of our key, I'd say, value propositions of this new solution is working with this manufacturer who has legacy systems. We are working on a framework on how do you convert brownfield to the new solution. So again, that's a high risk, and that is a risk we acknowledge and our partner acknowledges, and that's something we are addressing as part of the solution development here. And then just one final slide here before I hand over back to Richard around key takeaways. From a platform perspective, again, the key elements that I would like to present to you as part of my takeaway on the solution we're developing is, analytics is going to be a key. I am not going to, AI wash you with what sort of analytics are going to be AI enabled. I just want to put it out there that we as a company and as a product team, we are using AI to develop the product. We are using AI to be part of your journey as you implement the product, and then AI being sort of the guiding force, the augmented force for your manufacturing engineer, for your IT/OT engineer and your operator. And then, the core elements is what you're seeing on the screen is, the core being central configuration, so all of your models being configured, and then on edge execution is what's driving your execution. And then extensibility. This is not that we are creating a closed platform. Our goal is to make it extensible, whether it's via connectivity through MCP servers or on the OT side connectivity via MQTT, via Kafka, or any other protocol or latency or manufacturing bus that you have. We want to make sure that we can address those connectivity issues. And then from a UI perspective, like I said, the form factor doesn't matter, whether it's you're looking at a mobile display or a kiosk, or it's a true operator client. We are addressing all of those different form factors. So again, that's kind of our platform view. Again, my key takeaway is, going back to those sort of challenges and going back to the solves. As you go back, after this webinar, as you go back and think through your challenges, how are you addressing that? And is there a way for us to work together to address those? Okay, with that, I'll hand over to Richard to conclude this.
Thanks a lot, Vikram. So just wrapping up, and this slide here summarizes a lot of what we were talking about. In terms of those interfaces and the application of AI, I don't want to AI wash you, but that ability to say, okay, what's been my most common reason for downtime? What was the things that caused those downtimes? What shift was running? Whatever. Being able to superpower a person to be able to have additional level of interrogation. So the takeaways. First thing we covered was just around challenges. The current automotive market is hugely volatile. We are seeing onshoring, we're seeing supply chain issues, we're seeing new products coming in at a much faster pace than we used to, converting to EVs. There are huge headwinds for the automotive manufacturers, and the legacy systems hamper your ability to respond. So the outcomes you wish to see? Automotive MES providers must adapt to provide the agility to respond. We must provide solutions to you guys that allows you to be agile, either in terms of the manufacturing process itself to be agile, but also the ability to bring in new systems quickly as well. And then to provide the tools, like we were just covering, to enable continuous improvement and the application of artificial intelligence. Those tools are hard to apply with the legacy systems. But if we do the right things for you here in terms of our solution, what we're developing, that will provide that ease of use. So we are developing a platform. Requires a way that we change requires that we change the way that we build these systems together. We need more input from our customers to make sure we're doing this right. We are addressing your needs. We need to change the way we build the systems, and that's what Vikram just talked about. And we are building that next generation MES platform for the automotive market, working with our customers and future customers. And so the closing number 4 here, at the end of this slide, on the next slide, you'll see a 2D barcode. We need your input, as we've said. So if you can scan that 2D barcode after we've finished, you'll get 3 simple questions. It won't take you more than 3 or 4 minutes to actually respond that. So we'd really appreciate your input to go on that survey. Just help us prioritize where we invest our money. The second part of that is, Vikram sort of alluded to this, we have a beta program. It's kicking off in the second part of 2026. We want to work with customers. We have a key customer that we are working with on here. We are working with, but we'd like more. And so please do reach out to us. Our contact details will be on the next slide. We want to get engaged. We'd love to have more customers involved in that beta program. So on to the last slide. We have some time here for questions. I think just a few minutes. There's the 2D barcode. So please scan that and respond to the survey. And on that note, thank you very much for your time. Are there any questions at this stage?
Excellent.
I'm going to hand it to John now. Yep.
Thanks, gentlemen. We do have questions. We are running out of time, but we'll get as many as we can here. Mr. Gupta asks, how do you keep the application running for the operator if you lose server or cloud connectivity?
That's a great question. So again, I'm not sure if you got a peek at the platform slide that I had, but we have a configuration component that stays in the cloud, and then we have an edge component that stays in on the plant, so inside the plant walls or close to where the execution is happening. And then we have a sync mechanism with that configuration server for any of the execution runtime data to be synced with a centrally stored database or centrally stored runtime data. So yes, that's how we allow the operator to continue running. The configuration allows you to set aside, do I want to run an entire shift? Do I run a day's worth of orders? Or do I want, that timeline is flexible. It's up to you and how you set up the execution side of things to run.
Okay. Let's see, super quick, because we are running out of time. What is the total cost of ownership for upgrading an existing system?
So if you think about your total cost of ownership on especially SCADA-based systems, so think about the server farms you're probably running in your plants. So all of those servers, whether they're VMs or bare metal, the software on it, the databases, the operating system, and then the patches that, or the CVE related, the security related patches that either the OS vendor or the software provider has to send you, right? So all of those from a cost of ownership perspective, in a lot of the automotive plan, the cost expands over years. So if you have like 20, 30 plants, you're spending all of those IT resources to go upgrade those systems across those plants and across those server farms and across those multiple sites. So again, from a dollar perspective, it's probably from your end, it should be an easy calculation. Servers times, the time of the IT cost that I have, that should quickly give you a total cost of ownership of maintaining those systems. And then not to mention database maintenance, right? So all of this data that you're collecting, whether you're historizing them in the plant or your cloud connectivity, your cloud hosting costs for that data. So all of those add up fairly quickly, and these are not small numbers based on what we've seen.
Okay, well, that is all the time we have for questions today. Please join me in thanking Richard Porter and Vikram Mankar, as well as our sponsor, Velotic. If you have any additional questions, please email webinars@bnpmedia.com. We'd be happy to answer them. When you exit the webinar, you'll be taken to a brief post-event survey. Please take a moment to share your feedback. That'll help us improve our programs. Please visit assemblymag.com to see the recording of this presentation and to get information about our upcoming events. So, until next time, folks, keep after it.